Hello students, I am Tasfai Nafo. I'm going to give you a lecture on electrical machine 1. So under this course we're going to cover five chapters. First chapter it deals on the introductory parts of the DC machine, and next we'll cover armature windings of the DC machine, and the third chapter we're going to cover about the DC generators, including their principle of operation, classification, and their thermal characteristic curve. And as chapter 4, we're going to cover DC motors, and lastly, we're going to present the speed control of these DC motors. So, this is the learning objective of our course. At the end of the course, the students or you are expected or should be able to understand purpose of electrical machines and the classification of DC machines. It means types of DC machines, and we're able to differentiate the generators and the motors, and we should be able to understand the construction of the DC machines, identify the parts of the DC machines, and finally you have to make sure that you have to have a knowledge of assembling and reassembling of these DC machines. So today we'll continue in chapter 1, introduction of DC machines. So under this title we're going to cover these outlines, the introductory part, what electrical machines are, applications of the DC machines, and their classifications. So as an introduction, what is electrical machine? When we say electrical machine, these are the devices that convert either mechanical energy to electrical energy or electrical energy to mechanical energy. An electrical machine which converts mechanical energy into electrical energy, we call it as a generator. And a machine which is converting electrical energy into mechanical energy, we call it as a motor. So, since any electrical machine can convert either direction energies, it means from mechanical to electrical or electrical to mechanical, this machine can be either a generator or a motor. It means. This means that there is no major physical difference between generator and the motor. Both can convert energy from one side to another side. So this will come to it in detail later on. Anyhow, most of the DC machines are similar to AC machines. We may classify machines as AC and DC, and they are similar internally. All the machines, they generate AC internally, or they induce AC internally, but with the help of some extra devices which are connected to their shaft, this DC machine, they converted the internal generated AC machine into DC. It means AC machine to DC. So DC machines have a DC out just because they have a mechanical converter called commutator. See this is a machine. So this part, it is called a commutator. This part is commutator, and this is we can say induction motor or machine. It has no commutator. So the physical difference of these two machines is this part. Commutator, of course, there is an additional cold brush and it's holding inside. So this special material, we call it a commutator, and its intention is to convert internally generated voltage or current into DC. So due to this, DC machines, they are called commutating machines because they have a special component called commutator which enables these machines to convert internally generated voltage and current to DC machine. To DC. Therefore, DC machines are broadly classified into two: motors and a generator. A motor, like I said previously, it used to convert electrical energy to mechanical energy with the principle of Faraday's law. What Faraday's law says, when a current carrying conductor placed inside the magnetic field, it experiences a force, he said. It experiences a force. What does that mean? For example, if we have a magnetic flux density B, and if we placed a conductor inside this magnetic flux, conductor having L length, so what Faraday says, this conductor, it experiences a force, he said. That force, normally, that force, it is, sorry, my writer is stuck, it seems. So that force, which is experienced by this conductor, is going to be B L I sine theta, he said. So this B is a flux, and L is the length of the conductor placed inside the magnetic flux density, and I is the current which is flowing inside this conductor. And this theta angle, it is the angle between the magnetic flux density and the conductor, what we call it theta. Obviously, when this theta is going to be 90 degree, it is going to be the maximum force. And this force, it is the one which makes the machine or the motor to rotate normally. So, when we place a current carrying conductor inside the magnetic field, it experiences a force that is what we call it the motoring action, or Faraday's law. And when we come to the generator, which is a device which is converting mechanical energy into electrical energy. Again, it works based on the principle of Faraday's law of magnetic induction. What this law says that whenever the conductor cut by the magnetic field, EMF is induced inside the conductor, he said. Sorry, let me erase this. And Faraday's law of magnetic induction says that when we place a conductor, it is the north and the south, and obviously magnetic flux is flowing, and if conductor is placed inside this, it says it induces the voltage. The induced voltage normally, he said that it is B L U sine theta. So B is the magnetic flux density, which is emerged from the main pole, and L is the length of the conductor placed inside this magnetic flux density, and U is the speed, velocity at which this conductor is rotating or moving inside this magnetic flux density. And sine theta, obviously, it is the angle between the conductor and this flux. So it induces this much voltage when we place conductor inside the magnetic flux. Therefore, when we say DC machine, we mean that either DC generator or motors, and this machine, they convert this electrical into mechanical energy into electrical energy. And the main advantage of DC motor is that it is easy to control their speed in a wide range. It means that may raise the question why we need DC motors, because there are a number of DC AC machines out there. or AC motors are there. So the main advantage of using DC motor, they are easy to control the speed. Applications where we need regulated speed, DC motors are preferred. Obviously, these DC generators are quite rare today because already there are rectifiers are produced or they are invented. As you know, rectifiers they converted AC to DC. So with the production of this or with the invention of this electronic rectifier, the application of DC generator in the market today it is very rare. And the next point is the application of DC machines. Where we need to apply this DC machine. DC machines, they can be operated as a generator or motor, like we said previously, and they are applicable for different applications. And generators, they are quite limited, like we said previously, but motors are still, they have a wide range of applications. Large DC motors, they are used in machine tools, printing presses, fans, pumps, cranes, paper mills, traction, and extra. Number of DC applications are there today in industries. And when you come to smaller DC machines, smaller capacity means fractional horsepower, less rated power DC machine. They are primarily used for controlling purpose, such as in taco generators for speed sensing and servo motor for positions and tracking purpose. We usually apply DC or smaller DC motors. This is the applications where we can apply DC motors in the paper mill, in the steel mills. We apply DC motor because they have strong torques. They can carry huge loads with high torques. In the mining, in the machine tools, petroleum chemicals, in the robots, and extra applications are there in industry today. So let us come to the classification of electrical machine. When we come to this, electrical machine broadly classified into two: the stationary part and the stationary electrical machine and the dynamic electrical machines. And what are the stationary electrical machines? In such type of machine, there is no moving part and they remain stationary throughout their operation. A good example for such type of electrical machine is a transformer. Basically, this is a power transformer because there are different type of transformers are there. This power transformer, it converts energy from one form to another form. Basically, it converts electrical energy into the magnetic energy, and that magnetic energy again converted to electrical energy, and it will give you stepped up or down type of signal will be produced from such type of machine. This tells you directly, it converts electrical energy to mechanical energy, this transformer, again to electrical energy based on the winding and the way the transformer is connected. And this transformer internally, it has two main winding. Primary winding we call this if it is used connected as the primary, and this is secondary winding. So when current is passing through this conductor, this winding, obviously it produces a flux and it induces a voltage with the Faraday's principle of laws. And this induced flux will going to link the secondary coil and induces the voltage on the secondary coil. We call it a transformer action. And this machine, it converts electrical energy to magnetic energy, and this magnetic energy again converted to electrical energy at the secondary part based on the number of turn of the windings. Here there is transformer relation, what we call turn ratio. N of the primary to N of the secondary should always equal to induced voltage of the primary, induced voltage of secondary, which we call turn ratio A. So based on this turn ratio, our transformer may step up or down the input voltage based on their turn ratio. Anyhow, this type of machine, while it is operating this operation, or we mean when it is stepping up or down, nothing to be rotated, it operates being stationary throughout its life. So, say type of machine, we call it this static electrical machine. And the second type is dynamic electrical machine. This type of machines, they have both moving part at the same time stationary part. Good example for dynamic electrical machines are motors and generator. Motor, they convert electrical energy into mechanical energy. We have seen it. It has a rotating part. It has a rotating part and it has a stationary part. This is an induction motor normally. So the middle one, it is called the rotor. It is a rotating part, the movable part. And the outer part, it is called stator or the stationary part of it. The stationary part of it. And this electrical motor generates mechanical force due to the interaction between mechanical field and current in the conductor. Like we have seen in the previous section, it operates with the principle of Faraday's laws. What it says, when we place a conductor carrying current inside the magnetic flux, it says that the conductor will experience a force. That force that makes the motor to rotate normal. And a generator, it converts mechanical energy to electrical energy. In this machine, like we have seen in the previous section, if we place conductor inside the magnetic field and move the conductor with a certain speed, it induces the voltage what Faraday investigated. And we can also classify these machines based on their supply, DC and AC machine. DC and AC electrical machines. When we say DC electrical machine, we mean direct current. In this type of machine, they produce or they will be supplied with DC source, which is not having a frequency. And if we supply a smooth constant magnitude to the machine, we call it as a DC. And if it is supplying or accepting as supplies this type of signal who has alternating magnitude plus with minus, we call it is called alternating current. So electrical machines can be DC and AC machines. And there is another general classification of electrical machines. Broadly, electrical machines can be classified into DC and AC. And the AC part, I will not going to cover it because this is going to be machine 2 course. And the DC part, they are basically classified into commutator and homopolar type. These machines having one commutator, having a commutator, we call it a commutator type of DC machines. And if it is not having commutator and the unipolar, we call it homopolar type. And again, commutator DC machines can be classified to permanent magnet and wound field type. And if the machine field is produced by the magnet, we call it permanent magnet. And if the field is produced artificially by current, we call it wound field type DC machine. Again, wound field type can be further classified into separately excited, compound, shunt, and series one. In this separately excited, if the field winding is separated from the armature winding and can accept a different supply, we call it separately excited type. And if the field windings and the armature windings are supplied with one supply, we call it as a, supply, it is called a compound type. And shunt type, when the armature winding and the field winding are connected in shunt or in parallel, we call it a shunt type of machine. If the armature and the field windings are connected in series, we call it a series type. Again, further, compound type of generator can be long and shunt, and again this long can be cumulative, long can be differential based on the way the winds are connected. We'll come to these points later on in detail when we talk about generators and motors. These are the general classification of DC machines. This is what I have for today. Next, we'll proceed on the construction of the DC machine. Thank you for listening.